Today we're going to talk about hyperbolas. Yesterday we defined an ellipse as being the set of all the points so that a couple of distances that we measured, their sum remained constant. A hyperbola is defined as being the set of all points so that a point on the line and the distance to those 2 points called the foci, the difference remains constant. So points D and C here will be our foci. And then I have point A here, and the measurements from A to each of the foci are given here. This D value is the difference of those measurements, so subtracting those measurements. And for a hyperbola, that difference should remain the same. So as I slide these points around, we can see that in our list that D value is always remaining the same, that distance is always remaining 6, except for where it disappears, because we'd be taking the square root of a negative number. So as long as the distance is defined, the distance is 6, and we get these two branches across from each other, and this is called a hyperbola. So a hyperbola is defined as the set of all points so that those differences between any point on the line and the foci remains constant, that the differences there remain constant. When we have a graph of a hyperbola, we have a couple important features. Our center, again, is going to be at the origin for today. We're going to have some vertices that the hyperbola is going to go through. And there will always be two pieces to the hyperbola across from each other. Another important feature is that we are going to have some asymptotes that are going to define the width. Okay, they're not going to be horizontal or vertical asymptotes. They'll be diagonal line asymptotes that tell us how wide that hyperbola is going to be. The hyperbola will follow along those lines and be closed in by them. And we also have some foci that will be inside of the curves. The good or bad news about a hyperbola is that it is very similar to what we did yesterday. If you felt good about yesterday, hyperbolas work a lot the same way. If you didn't feel so great about yesterday, you get more practice because they work a lot the same way. The equations are almost the same as what we had yesterday in that we still have squared stuff and fractions equals 1. What's the major difference here between this and the ellipse we looked at yesterday? This one has the subtraction. So in the equation, the way we can tell the difference is if we're adding, that would be the ellipse, and if we're subtracting, that's going to be a hyperbola. Yesterday, x always came first. With a hyperbola, x or y can come first, and the letter that comes first defines the direction. So if x comes first, it's in the x direction, it's horizontal, as opposed to if y comes first, it's in the y direction, it's vertical, that our branches would open up and down instead of opening left and right. We're not going to really worry about the equations of those asymptotes. We'll be graphing the asymptotes into the picture, but we don't need to worry about the equations to do that. And the vertices should be defined by the direction. So if it's in the x direction, the vertex value will be in the x part of the position. If it's in the y direction, then the vertex will be in the y part of the point. Okay. Underneath, we have an equation that talks about the foci like we did yesterday. Yesterday, for an ellipse, we subtracted in our focus equation, and today for a hyperbola, we add in that focus equation. So a hyperbola is almost exactly the opposite of an ellipse. It's kind of like an ellipse turned inside out. Okay, so an ellipse adds, a hyperbola subtracts in its general form equation. So this problem asks us to draw the ellipse. So first step is we need to get standard form. So like yesterday, what do we need to do first here? Divide by 36. Standard form is that we should have fractions of stuff equal to 1. Reduce those fractions. Then to graph, today our center will always be at the origin. Yes.
When you're reducing, everything doesn't cancel out nicely like that. You still have numbers on the top.
You cannot have a number at the top, so you would have to think about dividing by a reciprocal then. You must always just have a plain variable on the top and nothing left on the bottom. Yes.
So are those numbers always going to switch? Like when you
Usually, but not always.
So if like they didn't, then would it not work?
It would mean there would be some reducing to do somewhere in there. So then, under the x is a 9, like yesterday, we're going to take the square root of that value. And since it's under the x, we're going to go out that far on the x-axis. If x comes first, that means our vertices are the x values. So as I go out 3 to the right and 3 to the left, I plot some points, and those points will be our vertices. Then like yesterday, under the y is a 4. So I'm going to go up and down 2, but I'm not going to put points there. I'm just going to measure out where 2 is. And instead of placing points, because those will not be points on our hyperbola, I'm going to use those heights to make a rectangle that goes through the vertices. The asymptotes will be the diagonals of this rectangle. So they'll go through the corners and through the center, making an X. And our curve will then follow along those asymptotes and go through the vertices. And in our equation, since x came first, that means this was a sideways one. If y came first, it would be at the top and bottom sections. A common mistake that students make when drawing these is to try to take those hyperbola branches all the way into the center instead of stopping at the vertices. Those hyperbola branches should not go inside of that rectangle. Okay, they should hit that rectangle and bounce off to turn back around.
So all of our graphs should look like that with an X and a box and a hyperbola.
Yes, so your graph needs all of those things on it, the X, the box, and the two curves. They might be the up and down, or they might be the side and side, but all those pieces need to be there. This question didn't ask for it, but some of your homework questions will. So we're going to say, what if you were asked to find your vertices? The vertices are these points where it made its turn. They're on our x-axis, and they were out 3. So 3 goes in the x position. You can do this without graphing, just by looking at the fact that x comes first, and taking the square root of that number and putting it into the x part of the point. So if all you are asked for is the vertices, you don't actually have to graph to find them. If x comes first, it goes in the x part of the point. If y comes first in the equation, then it goes in the y part of the point. And we take the square root of that number to go on the bottom of the fraction.
And so you said, like the determining factor with hyperbolas are facing sideways or up and down is the x came first, so it's going sideways, and if the y came first, it will.
Yes, so the direction is determined by which letter comes first, unlike the ellipse, which was which number's bigger. Okay, so yesterday we cared about which number was bigger. With a hyperbola, we care about which letter is first. In some of your questions, you will also be asked to find your foci. To find the foci, we need to use the equation that was below the box or chart in the notes, which was c squared equals a squared plus b squared. Like yesterday, a squared and b squared are the numbers in the equation. We don't need to square them. They are already squared when they are in the equation. So c squared equals 13. And c is plus and minus the square root of 13. And like yesterday, our foci should line up with the vertices, so our value should be in the same part of the point there. Yes.
Wouldn't that be a negative 4 squared? Because it's minus y over.
We're just taking the bottom numbers, the fractions, and the rule is a squared plus b squared. So we're ignoring the negative of the equation, just taking the bottom value of the fractions.
Is the first fraction the bottom number? Is that always going to be a?
Yes. If we would plot those, they have to be further out than the vertices because they should land inside of the curves. So the square root of 13 is somewhere between 3 and 4. So those foci would land past the vertices, which they need to. They need to be inside of the curves. So you can kind of check your work that way, that if you get something too small, it'll be inside the rectangle. And they need to be inside of the curves. Let's try another one. What do I do first? So I get x squared over 16 minus y squared over 9 equals 1. Then to graph, center at the origin. Under the x is a 16, so I'm going to take the square root of that and go 4 in each direction on my x-axis. Under the y is a 9, so I'm going to take the square root of that and go 3 in each direction on my y-axis. But those don't make points. We use the second numbers to create a rectangle. Draw in the diagonals of that rectangle, going through the corners and the center. Those will be your asymptotes. And since x came first, this one should be sideways, following along the asymptotes and bouncing off when we hit the vertex. If y came first, it would be in the top and bottom sections. The letter that comes first decides the direction.
The Y ones.
Still the vertices, which would be the edge of the rectangle. The vertices, if we needed to give them, we can get from our picture if we've graphed, or we can get just straight from the equation that x comes first, take the square root, so in the x part of the vertex should be a positive and negative 4. For the foci, we need to use the equation c squared equals a squared plus b squared. A squared and b squared are the numbers in the problem, so 16 and 9, which add to give 25. So our c is plus and minus 5. And the focus value belongs in the same part of the point as the vertex value. If we would plot them, out a distance of 5 would be far enough out that they would be in the curve. Questions? Our next problem asks us to write an equation. So we're going to start with the standard form, which is a fraction minus a fraction equals 1. Yesterday we could put the x squared and y squared in there because we knew x squared always came first. But with a hyperbola, either letter can come first. So we have to decide which letter is going to come first and place the letters, and then we have to figure out what's going to go under those letters. In the vertices, we are given that we have a 2 in the y position. The letter first decides the direction, so if the vertices have a number in the y position, that must mean that y is what came first. This is going to be an up and down facing one. Since the number in the vertex is in the y position, that means y came first in the equation. And then what are we going to put into the equation? A 4. We square the number of the vertex to go into the equation. So x squared must come second, but we don't know anything about an x value in our points because the focus that we're given also has its number in the y position. What letter talks about focus? C. So our focus is defined by C, so that means we're going to have to use the equation c squared equals a squared plus b squared to find that second number for our equation. So C is the focus number, which is 3. A is the vertex number, which is 2. And we don't know B. So we get 9 is 4 plus b squared. 5 is b squared. We could find b, but we don't actually care what it is, because in the equation, everything is supposed to be squared. So we can just put the 5 right into the equation. So we determine what letter comes first by the part of the point that has the number. We square the vertex value to get the one denominator, and we have to use our Pythagorean theorem equation to get the other denominator. Let's try another one. So our standard form is fraction minus fraction equals 1. What letter is going to come first, and how do I tell? Y is going to come first. How do I tell?
Because the numbers in the one.
Because the numbers are in the y position. So since our numbers are in the y position, y has to come first, and x has to follow. What's going to go under the y squared? 9. The vertex value squared. Then we use our focus value as C and our vertex value as A to find the other denominator. C squared is A squared plus B squared. So 5 squared is 3 squared plus B squared. 25 is 9 plus B squared. So 16 is b squared. We could find b, but we don't really care because in the equation, everything is supposed to be squared.
Well, we would care if we were graphing.
If we were graphing, we would need to square root that to be able to plot the point, yes.
So that is like the x-intercept for the rectangle we're making?
Yes, that would be, yes, the x boundary of the rectangle that we'd be making to find the asymptotes. For your homework, some modifications. Instead of 21, 27. And instead of 39, 36. Also, on numbers 33 and 36, you do not need to give asymptote equations. So it says to graph and then to identify the foci and the asymptotes. The asymptotes need to be present in your graph, but you don't have to give me an equation for them. You do need to give me the points of the focus, though. Okay.